Here we are discussing an interesting and important question from the chapter Relations and Functions. Question is basically based on the topic functions. Here question is, let A be a set and A is equal to R. R is set of real number. R minus this set having element 3. And B is equal to R minus set with element 1. And let f is a function defined from set A to set B and defined as fx is equal to x minus 2 upon x minus 3 for all values of x belonging to set A. Then we have to show that this function f is 1, 1 and onto function. Solution is very interesting here. Let us see the solution. First of all, we will show that this function is 1, 1. You know that for showing a function to be 1, 1, we show that if two images are equal, same, then corresponding pre-images in domain are also equal, then function is called 1, 1 function. So let us start with, let f of x1 is equal to f of x2. Here we have to show that then pre-images x1 and x2 in domain are equal. Then it will be known as 1, 1 function, correct? So fx1 is equal to fx2 implies from here x1 minus 2 by x1 minus 3 is equal to x2 minus 2 by x2 minus 3. Now we have to simplify it. We will get here x1 is equal to x2, or this implies by cross multiplication x1 minus 2 into x2 minus 3 is equal to x1 minus 3 into x2 minus 2. Let us simplify it further. Here we will get x1 into x2 minus 3x1 minus 2x2 plus 6, and in right hand side x1 into x2 minus 2x1 minus 3x2 plus 6. Here x1 x2 will be cancelled out from both sides. Here 6 will be cancelled out from both sides. By solving it, if minus 3x2 is transposed to left side, then 3x2 minus 2x2 is x2, and minus 3x1 is transposed to right hand side, then 3x1 minus 2x1 is x1. So we are getting here, this is x1 is equal to x2. So here fx1 is equal to fx2 is implying that x1 is equal to x2. Therefore, function f is 1, 1 function. Now we have to show that this given function is onto also. So for showing that this function is onto, we need to show that for all values of codomain, or you can say range, we are getting pre-image. Okay, for every element of codomain, we are getting pre-image in domain. Then this function will be onto function, correct? So here we will suppose that y belongs to set B. Let y belongs to set B such that y is equal to x minus 2 upon x minus 3. Let us simplify it and we will express x in terms of y, okay? Or xy minus 3y is equal to x minus 2, or here x will be common when this x will be transposed to left side. So y minus 1 is equal to 3y minus 2, or x is equal to 3y minus 2 by y minus 1. Okay, now you check the condition. Here B is codomain, which is equal to r minus this set 1. So this value of x will not exist when y is equal to 1. Correct? So clearly here y is not equal to 1. Otherwise something by 0 will not be defined. So we are satisfying this condition. B is equal to set of real number minus 1. Y should not be equal to 1. And secondly, set A means domain is equal to set of real number minus element 3. So we have to write here also x should not be equal to 3. Correct? Because if x is equal to 3, then here 3 minus 3 will be something by 0, which will not be defined. Clear? So it has been satisfied, justified that y should not be 1 and x should not be 3. Now fx is equal to x minus 2 by x minus 3. In place of x, we have to write this corresponding value. So x minus 2 means 3y minus 2 upon y minus 1 minus 2, and x minus 3 is 3y minus 2 by y minus 1 minus 3. When we will simplify it, simplification is very simple, because this can be written as 3y minus 2 minus 2y plus 2 upon 3y minus 2 minus 3y plus 3. Denominators y minus 1 will be cancelled out. Okay, here minus 2 plus 2 will be cancelled out, and here 3y and minus 3y will be cancelled out. 3y minus 2y is y, and here denominator is 1. So this is equal to y. Clear? So we are getting fx is equal to y. What does it mean? It means that if y belongs to codomain, therefore for all y belonging to set B, there exists pre-image in x, and this pre-image x is equal to this much. So as for every value of y belonging to B, means codomain, we are getting pre-image in set A in domain. So this function is onto function. So for all y belonging to set B, there exists x in set A. Therefore f is onto function. Therefore f is onto function. So we are supposed to show that this function is 1 1 and onto. Here we are showing that this function is 1 1 function. Here we are showing this function is onto function. So it has been proved. Very interesting question, very important questions. Hope you have understood it. So remain in touch with these videos. We have to see some more important questions, and hope you have subscribed this channel. If not, please get it subscribed and share these videos with your friends also. And if you have any doubt, any clarification, or you want to give any suggestion, please write in the comment box. And if you are enjoying these videos, your likes are most welcome. Wish you all the best.